Hello everyone, my name is Mayowa. I'll be your anchor for this program, and I'll be explaining about or I'll be talking about what smart contract is essentially. And this program is actually organized by the Zuri team working with the block games, and I'll be using them as an example actually. So quick one, let's dive in. Introduction to smart contracts. Now, what are smart contracts? Or okay, before what smart contracts are, what are contracts actually? Now, contracts is an enforceable agreement between parties. It's essentially kept, just like if you want to go deeply, pacta sunt servanda. Now, meaning agreements must be kept. If you're interested and I'm interested, then we can flow together. That's the if and the then statement. If you're interested and I'm interested, then we can actually get married. If you're interested and I'm interested, then we can actually treat together. So a contract is just more or less like an agreement that must be met before we can actually transact. Oftentimes, contracts always lead to transactions. Yes, you signing off something, at the end of it, you people are going to either just agree on something, which is still the same contract, and transact on something. So, and you can't transact with something you don't agree with. Either it's actually the smart contract we're talking about or anything. Then you cannot, or maybe you might actually be forced. It might not still be your will. You might not even still trust the stuff you're working on and still want to agree with them. Now, that's the fundamental challenges, which is really embedded in contracts. Now, what are these fundamental challenges? We have trust, we have clarity and enforcement. Now, the trust aspect is the corruption and conflicts of interest of judges, bureaucrats and the rest of them, etc. The clarity, complexity of legal texts that requires expensive legal counsel for interpretation. If I don't trust you, we can't deal. If you're not clear to me, I'm not interested. Now, the enforcement aspect, those are lengthy procedures, time barrier claims, questions of jurisdiction. So, a question of jurisdiction. Now, you might be forced to do something against your will. That is, you really don't want to do this, but you're forced to do it. Now, any of these three is part of the fundamental, the main key points of the main key challenges you are facing in contracts. Now, this is going to bring us to what smart contracts are. Now, smart contracts are essentially the basic function that powers applications that's programmed, built on blockchain, such as Ethereum. Now, we have so many things in the space, and we'll be talking about Web 3.0. Yes, we've been talking about Web 3.0. More or less like, and you should be aware too of AI, artificial intelligence. Now, understand something. Smart contracts are digital agreements that execute contracts automatically based on real-world imputed data or real-world data inputs in the data, or real-world data imputed, or anything you want to call it. Now, the smart contract, now, do not forget, it's actually digital agreement, number one. Now, aside from the fact that I define contract as an agreement, now the smart aspect is digital aspect. Now, for example, we can liken them to this statement, the if-then statement. If condition A exists, then perform the function B. So now, if the conditions that the Zuri team is working with block games to train people in Web 3.0 and you are interested to learn, then you can simply come and learn under the ecosystem they are building. Now, that is a statement. So if you are willing to sell this particular item for me at 10 naira, then I can buy from you at 10 naira. So that's the statement, but this is going to lead us to a more advanced definition, at least for our level. Trying to say smart contracts are immutable computer programs that runs deterministically in the context of an Ethereum virtual machine as part of the Ethereum protocol. Now, more or less like programmable data that run itself, it's immutable, just like the uniqueness and the awesomeness of the blockchain technology. Immutability. No one can actually have a say over it. Once deployed, it's gone. Now, computer programs, smart contracts are simple computer programs. We are simple in this context. The word contract has no legal meaning in this context, actually, because at some point you might have heard people saying code is law, law is code. Now, the awesomeness, immutable, the immutability aspect. Once deployed, the code of a smart contract cannot be changed, unlike the traditional software. Then you can actually now build another one. So now say, oh, this is the version 2. Then you migrate possibly liquidity and the rest of it out of the first one. Now, immutability. It's not as if you're just going to change it. That, oh, I made a mistake. I want to edit this. I'll talk about this when I'm showing us the environment and talking about the life cycle when creating a smart contract. Oh, you've not even tested or audited a project yet on the testnet, then you're going mainnet. You're going to do all the big thing. Man, that's huge, especially on Ethereum blockchain. Now, the deterministic aspect, a simple way of thinking about this computation is the following. They either happen in full, exactly as described, or they don't run at all. That's when you have bug. Now, don't get me wrong. If you have bug, because of the deterministic nature, the bug will actually make it perform in a buggy way, something totally different from what you actually did or what you programmed, because a single change can change everything. Now, that's why you really need to test this thing because of the immutability. Of course, the EVM context here we're talking about is more or less like they can access their own states. Now, I will talk about evolution of smart contract actually. Now, this evolution started way back in 1997 by Nick Zambo. Now, he brought about the idea of smart contracts. You can actually Google that and read more. Now, from 97 to 07, that's 10 years, that's technically 12 years after, Satoshi Nakamoto introduces the concept of blockchain. And of course, you believe me, Bitcoin is the first implementation of the blockchain technology. Now, going through 2012 to 14, that's the origin phase. Everything is just starting. Now, the starter pack was around 1997. Now, around 12, 13, 14, 15, so many things has been happening. Some forked Bitcoin. Ethereum came in play. That's the experimentation state. Now, we are all experimenting back then and like, oh, will this work? If you used to use CoinMarketCap, I think way back to 2017, 18, some top coins then, some don't even exist anymore, while some are still standing strong. Now, as a matter of fact, the experimentation states, some died, some went off. Now, 2014-15, smart contract solution introduced. Bank and other companies set up labs to develop the proof of concept. I think this was, the light here was shed yesterday or a few days ago when we're talking about blockchain trilemma and the consensus algorithm, where we have proof of stake, proof of work, delegated proof of stake, proof of history, proof of bond, so many proof of concepts. Now, fast forward to 2019, 18, 19, we started having regulations everywhere, laws everywhere on the blockchain. Now, the mainstream adoption began in 2020. Yes, we are still in that phase. I think for the next 5 years, like from now to 2025, we should be seeing huge things in the space because of this mainstream adoption. Now, you won't get you won't misquote me if I say we'll always be having, smart contracts having few issues. I think that was what led to the deficiency aspect, or should I say, few things that can happen, because this is actually their computer codes normally. But as a matter of maybe few loopholes and the rest of them, a smart contract can be drained. Do not forget, smart contracts is just set of codes to run, and basically it keeps money if you're talking of the blockchain concept, because there's no protocol you want to do that has no money involved in it, and they are not DeFi in nature that gives you yield and you lock up your smart contract, because this whole thing is talking about the decentralized world. It's talking about node, it's talking about no central authority. Each and every one of us are trying to secure the blockchain space. Now, how do you create smart contract actually? Developing smart contracts can be technical at times, but actually not really so technical if you know what you're doing, but can be done in many ways actually. Technically be done in many ways. The question is your own. Which one do you want to pick? Which one are you satisfied with? Do you prefer the online or the offline aspects? You're talking about Ethereum, because for this program, we'll be dwelling on Ethereum blockchain, and you can actually expand on your general knowledge to learn more. But through a wizard like Etherparty, you can do this. You can use Mist to do this. Now, but the upgrade is everywhere, and life is being made easy every day. People are discovering, mathematicians are doing what they are doing in the space, because obviously they are the ones and the cryptographers behind all this proof of that. So now we have Remix, an online integrated development environment that uses Solidity and the rest of them. Like there was a Ethereum Studio before, but I think that's then. Now, this is the environment. If you don't know it, you can actually just Google it, Remix Ethereum. It's going to give you remix.ethereum.org. And good to be here. This is what we have. This is the old space. This is the old space. And one thing you should understand here is, well, this is the comment section. We can still call this comment actually. Now, the title part is the storage. Your smart contract, the name you're giving to your smart contract. What's the name? Ethereum, or let's say Midas.so. That's Solana. I'm sorry, Solidity. Solidity actually. Now, this Pragma Solidity is the current version. Now, you have the storage aspect. This actually stores, dev stores and retrieve value in a variable. Now, it stores all these things, what you're imputing, the uint 256, a number variable. Now, you have a storage. If you build, you store it somewhere. Okay, let me show us this life cycle of how creating a smart contract actually works. Now, this is the life cycle. You develop, that means you're creating. You come in here, you do your thing, function, it imputes, it retrieves data, you call what you want to call, you call a function, then you retrieve the function back in all this old space, and all this thing you're doing over here. I'm just trying to get us familiarized with this environment. Now, all these things is called your development stage. So you're developing. Now, an account will be assigned to you in the environment. Now, you can see the JavaScript virtual machine. Now, this virtual machine is just like a container that this smart contract actually runs on your computer. If you're talking of Ethereum virtual machine, Now, this account, if you see, what's it called? If you see a project on the blockchain, you always see contract address. Title storage, that's the name of what you're doing. Then the contract address is going to store in a particular address, and the byte code will now be uploaded on the network of once you're done. Everything will now pop up when you're compiling, and everything will have been shifted to a particular figure. Or let me call it I'm trying to break this down as easy as possible. You can actually break this down to your normal Ethereum address, because the Ethereum blockchain, just like you can see this address here for testing 100 Ethers each on the testnet, actually. Now, once you've done deploying, that's your deployment stage, you compile. And all these compilations actually still, maybe if there's anything, the code, there's anything wrong with it, and the rest of them, I mean, inside this online environment, the local one could be truthful, and you're not even going there. Now, once you're done compiling, you test. Okay, it's a bit specific. As for every change, you have to wait for the block to be mined. Go to testnet. This is what it's talking about, testnet aspect of it. Like use Wrinkle-B and the rest of them to test, so that you're not using the real Ethereum to pay for gas and the rest of them. Now, there's some testnet, there's some frameworks for testing locally, like the Ganache, and the rest of them like that. Now, once you're done, you deploy, meaning signing the contract and pushing the compiled binary code to the network. And imagine you didn't test a particular contract, all your sweat here, you didn't test this particular stuff, and you went to deploy, and this thing is having issues. You have yourself to be blamed because you've lost your Ether. Now, once you're done, you upgrade contract. Now, remember, you cannot destroy or stop it. Okay, let me use the word stop. Don't let me use the word destroy. Let me use the word stop. Now, you can't stop it from running. So now you have to do another one that will now tell you, oh, this is the version 2 of what I'm building. Then version 2 is actually here. Oh, continue or keeping on. Now you start all over again. So in the process of you doing the version 2 and the last step before destruction of smart contracts and the rest of them, it's the same thing as you're developing again. Then you go to compiling, to testing, to deployment, upgrading. So this is like a cycle. Now, sometimes to note, Ethereum virtual machine, I already said this, like a container on your system that makes this thing work, like JavaScript virtual machine and the rest of them. Now, the gas, you pick gas on the Ethereum blockchain. So that's why I said you need to test what you're compiling, what you've compiled. You need to test it if it's working properly or it's having bug, so that you don't end up putting this thing out there and your smart contract is getting drained because of bugs or so many things. Now, the fees, main reason why gas fees really needed is to pay validators and to spam measure. I think here you can talk about the proof of stake when we're talking about the consensus algorithm, and we're talking about blockchain trilemma, validators to secure it. You have to choose one, the security or the how fast it is. And I think what was the last one now? I can't really remember. Blockchain trilemma coming. No, I'm supposed to remember this. I think it's scalability. Yeah, scalability. Okay, yeah. Scalability, security, and decentralized. How decentralized is the protocol. So if you really want to learn more about all these things, I think some resource has been dropped. You can go back to the previous videos we had, the previous teachings. You will see where we talked about the concept of consensus algorithm and the blockchain trilemma. Now, also, this is good to make sure your contract eventually stops so that it doesn't keep running. Now, Fonda, okay, let me see. Okay, yeah, we have some here too. Transactions, yes, transactions. Transactions are functions, and if you actually transact or you do something, you can actually get it sent over the blockchain. You still pay for fee and the rest of them. So that is under transaction. I agree with you, you agree with me, then we transact together. Now, calls, contracts communicate among each other via calls, actually. And now, use cases. We have so many use cases, part of which we'll be mentioning just this. Now, for the manufacturing and supply chain aspect, large manufacturers need to follow thousands of ledgers and the rest of them. But with smart contract, this thing can actually automate itself, and its fish can be triggered automatically when all requirements are met. The vote aspect, gathering the vote and triggering actions, is one of main reasons why this is actually needed. Internet of Things, tracking data from IoT-enabled devices. Do not forget what I made mention of. And I use Zuri team, like the middleman, like an oracle. Like Zuri team is the oracle behind all of this, trying to tell you, if you agree, I will show you the real world experience and put it into code for you to learn. Then, yes, I want to agree with you. Then I'll come and learn. Now, the royal distribution aspect of it, like automatic payout of royalties, I think there's a protocol called Superfluid on Polygon that does this, automates payments, I think every week, every month, depending on how you set it. So all you're simply doing is you're locking up the money in there and it keeps working. So smart contracts are very, very, in fact, they are one of the best things that have ever happened to human, programmable way of keeping our funds safe and the rest of them. But there are a few issues we have in smart contracts are getting hacked, they're getting drained. But that's beyond the scope of this course. And I think one of this particular stuff Ethereum and Vitalik Ethereum talked about in, I think, 2018, he said, I think he regretted why saying, why calling the smart contract. He said he could have called it persistent scripts because they are just so awesome and they do more. So then the reference from this, okay, I think with this we're done with this introduction. So I believe this will actually get you started into the smart contract world. And coming to you, more videos will be coming in when we are launching deeply or when we are going deeply into this smart contract itself. But this is just the peripheral, the beginner's part, and let's go with everybody phase. Thank you very much and have a wonderful day.